Hello, my name is Ashish Sharma, and in our last lecture we discussed about Josephson effect and its type. I have introduced already DC Josephson effect and AC Josephson effect, and in this lecture we will discuss both type of Josephson effect in details. Okay, so first is DC Josephson effect. And what is DC Josephson effect? A DC current flows across the junction in the absence of any electric or magnetic field. So basically there is no voltage supply across the junction. So I hope you remember what is Josephson effect. Actually there are two superconductors which are separated by a thin layer of insulator. Okay, let me choose another color. So this green is insulating layer, and these are superconductor 1 and superconductor 2, and the width of insulating layer is from 10 angstrom to 20 angstrom, not more than this, otherwise there will be no Josephson effect. Okay, तो अभी अपन डिटेल से पढ़ते हैं कि जो डीसी जोसेफ्सन इफेक्ट है क्या हो रहा है इसके अंदर. एज आई ऑलरेडी मेंशन, देयर इज नो वोल्टेज सप्लाई इन डीसी जोसेफ्सन इफेक्ट. ओके, so as we know that from Schrodinger equation that H psi is equals to E psi. Here H is P square by 2m plus V of r, and this is potential energy, this represent kinetic energy, this is Hamiltonian. Okay, and E is nothing but iota h cut del psi by del t. Here we are discussing DC Josephson effect, and let the probability amplitude for superconductors electron psi 1 equals to under root n1 exponential iota theta 1 and psi 2 equals to under root n2 exponential iota theta 2. Here theta 1 and theta 2 are a phase difference, n1 and 2 are number density of electrons. Okay, here 1 and 2 are used for first superconductor and the second superconductor. Okay, because there are two superconductors separated by insulating layer. Okay, now since there is no voltage supply, since there is no voltage supply, so potential energy is 0 in DC Josephson effect. And P square divided by 2m is equals to h cut t. Here t is nothing but effect of electron pair coupling or transfer interaction. What I said? Transfer interaction. Because current flows when electrons penetrate through the this junction and transfer from first superconductor to second superconductor and second superconductor to first superconductor. So basically T is nothing but a transfer interaction from first superconductor to second and second to first. Okay, so our Schrodinger equations becomes E psi h psi is nothing but iota h ka del psi 1 del t is equals to, what is h cap? H cap is nothing but h ka t. This is transfer interaction. So if I writing here psi 1, then here I will write h cut T psi 2 second state, okay, means for second superconductor, plus V of R psi 1, but potential is 0. So this is our first equation, and similarly I can write for the second superconductor, and it will be iota h cut del psi 2 divided by del T equals to h cut T, and this time interaction between from psi to psi 1, so h cut psi 1 plus V of R psi 2, since potential is 0, so again this term is 0. So this is equation second. Now we have the value of psi 1 and psi 2, and psi 1 equals to under root n1 exponential iota theta 1. So del psi 1 divided by del T equals to 1 by 2 n1 minus half. First I am differentiating of n1 with respect to time, and then I will differentiate theta 1 with respect to time, okay. So this is equation number 3. So put this value in equation first. So what I get, iota h cut 1 by 2 n1 minus half del n1 upon del T plus n1 iota del theta 1 and del T, and I can take common exponential iota theta 1 equals to nothing but h cut T psi 2, okay. And if I transfer iota h cut in right hand side, then I can write 1 by 2 n1 minus half del n1 divided by del T plus n1 half iota del theta 1 del T exponential iota theta 1 equals to, this h cut will cancel out by this one, and when iota will transfer to the right hand side, it will becomes minus of iota T, and we know the value of psi 2, okay. Now multiply this equation by under root n1 exponential minus iota theta 1, and what we will got, 1 by 2 n1 minus half del n1 divided by del T plus n1 half iota del theta del T under root n1, because exponential minus iota theta 1 will be cancelled out from exponential plus iota theta 1, and in the right hand side we will get minus iota T under root n1 n2 exponential iota theta 2 minus theta 1. Further I can write it 1 by 2 del n1 divided by del T, because when I will multiply this term with the first term, then here is the minus half power and here it is plus half power, so it will be cancelled out, and in the second term half power plus half power will becomes the whole power 1 iota del theta 1 del T equals to minus iota T under root n1 n2 exponential iota phi. Here phi is nothing but phase difference, that is theta 2 minus theta 1. So I write in this equation the next equation, that is equation number 4, and also remember this equation number 5. This is nothing but phase difference. Okay, similarly we can do the same process for the second Schrodinger equation, that is for this one. This time I will differentiate psi2 with respect to time and put the value in equation second. So del psi2 divided by psi2 is nothing but under root n2 exponential iota theta 2. I will do the same process as I discussed till the equation number 4. Okay, del psi2, so n2 power minus half del n2 divided by del t exponential iota theta 2 is same, plus n2 power 1 by 2 iota del theta 2 divided by delta t and exponential iota theta 2. Put this value in equation second, so I get iota h cut 1 by 2 n2 power minus half del n2 divided by del t exponential iota theta 2 plus n2 1 by 2 iota del theta 2 divided by t, and I can take common exponential iota theta 2 equals to equals to h cut t psi 1, and psi 1 is nothing but n1 exponential iota theta 1. Here you can see in equation second, here this is equation second. Okay, now I will transfer iota h cut in the right hand side, so h cut will be cancelled out with this h cut and iota will becomes minus iota, so it will become half n2 power minus half del n2 del t. Okay, sorry, I have take it common, so it will not be here. Okay, plus n2 1 by 2 iota del theta 2 del t exponential iota theta 2 equals to, since this iota will becomes minus iota here, so minus iota t under root n1 exponential iota theta 1. Now multiply the above equation by under root n2 exponential minus iota theta 2. So I will get 1 by 2 n2 minus half del n2 del t plus n2 half iota del theta 2 divided by del t and under root n2, because minus iota theta 2 will cancel out with exponential plus iota theta 2, and in the right hand side I will get minus iota t under root n1 n2 exponential minus iota theta 2 minus theta 1. And what is theta 2 minus theta 1? Theta 2 minus theta 1 is phase difference, that is phi. So I can write 1 by 2, and if I multiply this inside the term, then I will get 1 by 2 del n2 divided by del t plus n2 iota del theta 2 divided by del t equals to minus iota t under root n1 n2 exponential minus iota phi. This is another and important equation, and this is equation number 6. Now take equation 5 and 6 and put the imaginary and real component separately. So I am copying equation 4 from here to here. You can assume later, or you can assume right now for simplicity, that both the superconductors are identical, and if the superconductors are identical, then we can write n1 equals to n2. You can assume it later or you can put it right now. This is all your choice. Okay, so I am putting this condition right now. So equation 4 becomes 1 by 2 del n1 divided by del t equals to t under root n1 n2, and this will be sine phi. Actually I am compare real and imaginary part. Okay, so exponential iota phi can be written as cos phi plus iota sin phi, and when I will multiply this term iota sin phi with minus iota, then I will get plus iota square will be minus, so minus minus will be plus. I will get plus t under root n1 n2 sin phi, and the real term on the left hand side is 1 by 2 del n1 divided by del 2. So I write it equation number 7. Similarly, for imaginary term, you can see that imaginary term in the right hand side will be minus iota t under root n1 n2 cos phi, and imaginary term in the right hand side will be iota n1 del theta 1 divided by del t. You can eliminate iota by iota, so equation 8. Similarly, we can break in the real and imaginary part for the equation 6, and from equation 6 let me copy it from here. Okay, and if I break this equation into real and imaginary term, so this time exponential minus iota of phi will be cos phi minus iota sin phi. So imaginary term will be n2 del theta 2 divided by del t equals to minus iota t under root n1 n2 cos phi. Okay, so let this equation number 9. I can delete iota from both sides, and real term this time minus iota, this minus and this minus becomes plus, then again iota into iota square, it will again becomes minus. So the right hand side will be minus t under root n1 n2 sin phi. Okay, and the left hand side will be 1 by 2 del n2 divided by del t, and let this equation is number 10. So basically we have now 4 equations. As a result, we have obtained 4 equations as a result, and there are 2 equations are 7 and 8, and 2 equations are 9 and 10. I put these 2 equations from here to the final result. So these 4 equations are important, equation 9, 10, 7 and 8, because when I put n1 equals to n2, then from equation 8 and 9, then from equation 8 and 9, of course, from equation 8 and 9, you can see here equation number 8, the right hand side have minus t under root n1 n2 cos phi, and now n1 n2 are same, similarly in equation number 9, minus iota, iota is cancelled, minus t under root n1 n2 cos phi. Since n1 and n2 are same, so right hand side becomes same, so left hand side also will be same, that is n1 del theta 1 divided by del t will be equals to n2 del theta 2 divided by del t. n2 and n1 are equal, so I can write del theta 2 minus theta 1 del t equals to 0. And this is an important result for DC Josephson effect. Okay, and similarly we can obtain another important result from equation 7 and 10, from equation 7 and 10, because when we put n1 and n2 equals to each other, then we will get a result that minus del n1 divided by del t is equals to minus del n2 plus del n2 equals to del t. This is another important result. Okay, and this is as expected from our basic concepts. If an electron is transferring from first superconductor to second superconductor and second superconductor to first superconductor, then direction of current will be opposite. Okay, so this one, I again repeat, this one is an important result for DC Josephson effect. Okay, and here theta 2 minus theta 1 is nothing but phase difference. Okay, that is del phi divided by del t equals to 0. Okay, so this was DC Josephson effect, and now I can write another important result for the current, that is Z is equals to Z naught sine delta, or phi, because phase difference I assumed in upper calculation was phi. So J naught is maximum DC current for DC Josephson effect, and phi here phi is nothing but phase difference, so current's value can be from minus J naught to plus J naught, because sin phi take value from minus 1 to plus 1. This is not an AC current, because phase difference is not going to change every time. Okay, so there is no dependency on voltage of the current, so current is not depending on voltage. Okay, current is depending on phase difference, so current is going to be DC, that is remains constant across the junction. In the next lecture we will discuss in the previous lecture we discussed DC Josephson effect, and in this lecture we will discuss AC Josephson effect, and what is the difference between both the effects. The main difference of applying voltage, there is no applying voltage in DC Josephson effect, but in AC Josephson effect we apply a constant DC voltage or constant DC source across the junction, and in this situation there flows a current across the junction. Okay, so what is the difference between both the situations? Because this time we have applied a voltage source, then there will be potential energy too. So if we assume that potential energy for one side of superconductor is plus EV, then another side potential energy will be minus EV. Okay, here we have applied a voltage source of volt V. So if we assume that potential energy of this side of electron is EV, then another side of electron will be minus EV. Okay, so this time nothing is going to be changed, this process will be same, but this time the potential energy is not going to be 0. This is going to be minus EV for one side and plus EV for the another side. Okay, because we know that W equals to QV, so Q is charge on electron, so I am taking quanta of charge E, and V is applied voltage. Okay, so as we have discussed already, Schrodinger equations is nothing but E psi equals to H psi. H is Hamiltonian, nothing but P square by 2m plus V of R, and in this situation kinetic energy is represented by transfer interaction. Okay, and energy E is nothing but iota h cut del psi divided by del t, and we already know that psi 1 is nothing but under root n1 exponential iota theta 1 and psi 2 is nothing but under root n2 exponential iota theta 2. So from Schrodinger equation I am writing for the first superconductor, so iota h cut del psi 1 del t equals to h cut t transfer interaction, so from first to second plus v of r psi, and energy potential energy is minus ev psi 1. Okay, and for the another superconductor I can write iota h cut del psi 2 divided by del t equals to h cut t transfer interaction from psi 2 to psi 1, and potential energy will be plus ev. Okay, and psi 2. Okay, now it's your choice that you write here minus ev and plus ev here. You can choose alternate here, means you can write here plus ev and here minus ev, because we are not restricted that the first superconductor is at a positive potential or the second superconductor. Okay, so you can write anywhere plus ev and anywhere minus ev, result is not going to be affected. Okay, so I assume this equation first and this equation second. So psi 1 is nothing but under root n1 exponential iota theta 1, so del psi 1 divided by delta theta t is nothing but 1 by 2 n1 power minus half exponential iota theta 1 del n1 divided by delta t plus n1 plus half exponential iota theta 1 del theta 1 divided by delta t. Put this value in equation first. Okay, so what I got iota h cut 1 by 2 n1 minus half del n1 del t plus n1 plus half del theta 1 delta del t, and I take common exponential iota theta 1, and the right hand side will be nothing but h cut t psi 2 minus ev psi 1. Okay, I transfer this term in the right hand side, so h cut will be cancelled out, and here I will divide it by h cut, and when iota will be transferred it will becomes 1 by 2 n1 power minus half del n1 del t plus n1 plus half del theta 1 del t exponential iota theta 1 equals to minus iota t psi 2, and this one becomes plus because this iota will be minus iota, so it will become plus iota ev divided by h cut and psi 1. In the same process as we discussed in DC Josephson effect, multiply the equation by psi 1, that is under root n1 sorry, this is not psi 1. Multiply the equation by under root n1 exponential minus iota theta 1, so I will get 1 by 2 n1 minus half del n1 del t plus n1 half del theta 1 delta t, and here I will get n1 half because this term will becomes exponential 0 after multiplying with this term, and the right hand side will be minus iota t under root n1 n2 exponential iota theta 2 minus theta 1 and plus iota ev upon h cut n1, because under root n1 and under root n1 will becomes n1, and exponential minus iota theta 1 and exponential plus iota theta 1 of psi 1 will be cancelled out. So multiply this term inside, so I will get 1 by 2 del n1 divided by delta t plus n1 del theta 1 divided by delta t. I have forgot writing iota here because when I will differentiate with respect to theta, then this iota will come here. Okay, sorry for this inconvenience. Okay, and in the right hand side we will have minus iota t under root n1 n2 exponential iota phi, because phi is nothing but theta 2 minus theta 1, plus iota ev upon h cut n1. Now we can break it into real and imaginary part, since we know that exponential iota phi is equals to cos phi plus iota sin phi. So the real part of right hand side is nothing but 1 by 2 del n1 divided by delta t, and the real part of the right hand side will be obtained when I will take this term, because this iota and this iota will becomes real. Iota square will be minus 1 and this minus 1 will be plus, so I will get t under root n1 and 2 sin phi. This is an important result, so since this is equation number 3. Okay, and imaginary part, as we know that imaginary part in the right hand side is left hand side is nothing but n1 del theta 1 divided by delta t iota, and in the right hand side I will get imaginary term with cos phi and this term. Okay, so this is nothing but minus iota t n1 n2 cos phi plus iota ev upon h cut n1, and I can delete iota, so I will get n1 del theta 1 by delta t equals to minus t under root n1 n2 cos phi plus ev divided by h cut n1, and this is equation number 4. So I have obtained both real and imaginary part from the first Schrodinger equation, and similarly I can do it for the second Schrodinger equation, that is for the psi2 state. Means I can do it for this equation. Okay, you have to do nothing but you have to put the value of del psi 2 divided by del t, that is, we know that this is nothing but so I will get 1 by 2 and 2 minus half exponential iota theta 2 del n2 divided by delta t plus n2 half iota exponential iota theta 2 del theta 2 divided by del t. Put this value in equation 2 and I will get iota h cut 1 by 2 and 2 minus half exponential iota theta 2 del n2 del t plus n2 half iota exponential iota theta 2 del theta 2 divided by del t equals to h cut t psi 1 plus ev psi 2. And transfer the iota h cut into the right hand side, so I can eliminate h cut from here and can put here, and when iota will be transferred in this side I can write 1 by 2 and 2 minus half, and exponential iota theta 2 can be taken as common from the both terms. So this iota will becomes minus iota t psi 1 and minus iota ev divided by h cut psi 2. Now multiply by under root n2 exponential minus iota theta 2, and we will get 1 by 2 n2 minus half del n2 divided by del t. I think it seems too boring. This is nothing but pure mathematics. Okay, and still if you have any problem, then you have to work on your brain. Okay, exponential minus iota theta 2 and exponential plus iota theta 2 will be cancelled because it will become exponential 0, so it will be 1, and in the right hand side it will become minus iota t psi 1 minus iota ev upon h cut psi 2. If I multiply under root n2 inside the terms, then I will get 1 by 2 del n2 divided by del t plus iota n2 del theta 2 divided by del theta 2 divided by delta t. So okay, I have done some mistake. When I will multiply with this term in this equation, then I have to multiply in right hand side too. I have forgot. Okay, so I will get minus iota t under root n1 n2 exponential minus iota theta 2 minus theta 1 minus iota ev upon h cut, and I will get n2 because minus iota theta 2 will be cancelled out, exponential plus iota theta 2 of this term. And now separate real and imaginary terms. So 1 by 2 del n2 upon delta t is real term in left hand side, and the right hand side we can obtain that the real term will be from the sine term from the exponential iota theta t, and here is exponential minus iota theta 2 minus theta 1, so I can write it like exponential minus iota phi, and this can be written as cos phi minus iota sine phi. So minus plus iota will be again minus, so this will be t under root n1 and 2 sine phi. This is next equation, equation number 5, and the imaginary term will be iota n2 del theta 2 divided by del t equals to, imaginary term will comes from the cos term, so it will be minus iota t under root n1 n2 cos phi, and this is also an imaginary term minus iota ev divided by h cut and 2. This is equation number 6. So again we obtained 4 equations for AC Josephson effect as we obtained in DC Josephson effect, and these 4 equations are the result. Now further we can assume for simplicity that n1 and n2 that both superconductors are identical, and in this situation you can observe that from equation 6 and from equation 4, from equation 4, let me copy it from here. Yeah, here, since n1 and n2 are same, I can eliminate iota. Okay, so you can see that there is the same value minus t under root n1 and 2 cos phi, and there is also minus t under root n1 and 2 cos phi, so we can put the value of minus t under root n1 and 2 cos phi because n1 and 2 are same. So what we will get n2 del theta 2 divided by delta t, and this will become plus ev upon h cut. I'm writing from this equation, n2 equals to minus t under root n1 and 2 cos phi. Okay, And similarly you can write down the value of this term, so it will become n1 del theta 1 del t minus ev upon h cut n1 equals to minus t under root n1 n2 cos phi. N1 and n2 are same, so the right hand side of both equations are same, so I can write the left hand side's equations equals to each other. Okay, n1 and n2 are same, so I obtained again del theta 2 upon del t minus del theta 1 upon del t equals to minus 2 ev upon h cut, or I can write del upon delta t theta 2 minus theta 1 equals to minus 2 ev upon h cut. So this is nothing but del phi upon delta t equals to minus 2 ev upon h cut. This is the important result. We got a 0 for del phi upon delta t in DC Josephson effect, and for AC Josephson effect we are getting del phi upon delta t equals to minus 2 ev upon h cut. As I discussed